Hello, hello engineers. Am I audible? Okay, so today is a tool session, and today we will complete the RC class. Okay, so on Thursday, I think last Thursday we work on a tool session where we simulate R and C with that input of pulse. Okay, now I am going for diode based question. We discussed on that Thursday and Saturday the diode and switch. So now simulate it, okay, and check it that our response, okay, that will be help to you. Yeah, okay, how can you simulate it on LTSpice? Okay, and when we start a MOSFET, we start a cadence virtuoso. For RC circuit, you can use LTSpice. Okay, you can use LTSpice for MOSFET also, but for MOSFET, that CMOS inverter or common source amplifier or current mirror or differential pair, we will work on that. That is cadence virtuoso. Okay, so let's start with that. Okay, you have a question where we have a diode with RC. So just open that LTSpice. Just if you install it, just open it. So it will be like this, and you just go for new schematic. Here it has new schematic. Just click on this new schematic, and you have a schematic window. In this schematic window, you have a lot of option of that component. Like you have a voltage source, you have a resistor, you have a capacitor, you have an inductor, you have a diode, you have a components, lot of component they have. Okay, so you can use, okay, and inside this also you can explore as much you want. Okay, so let's start with that basic numerical. Okay, we have a voltage source. Okay, and if you want to escape that, if you want to remove from the mouse, just escape it. Okay, and you have a register. Okay, you can rotate it. You can press Control R, CTRLR, so it is rotate. Okay, and escape it, and you have a capacitor. So this is the basic circuit where we are connecting that. You have a resistor and you have a capacitor, and okay, and press W for wire, or you can choose this, that is wire, or you can use a shortcut key, that is W. Okay, and you have a ground here. Of course you required a ground. So this was the basic question. Now I am using a diode, so I am taking a diode component. So this is diode. Okay, and it have a direction is like this. So this is the direction of diode. Okay, and you simply connect it like this. Okay, you can, and firstly analyze at your point, and then go for what, then you go for as per the simulation. Okay, so you have a basic information. Okay, you know that you have a R and C, you have a voltage source. So the response was what? Okay, let just firstly put that value, that R is 1k. I am just putting that R is 1k, the resistance is 1 kilo ohm, and capacitor is 1 micro. So that the basic tau is what, that is 1 millisecond, and I am using that supply. So I am just designing that supply. Okay, we discussed last class we have a different that function, so you can use it for a supply. I am using a pulse width logic, that on the basis of that you can make your own waveform. So I want like just till 1 millisecond there is no voltage. Okay, in 1.001 means in 1 microsecond of after 1 millisecond the value become 10 volt. Okay, and it is maintained till 10 millisecond or any time. Okay, after 10.001, okay, sorry, that the value is 10. After 10.001 millisecond means after 10 millisecond you have a 1 microsecond of difference. The input is switching to 10 to 0. So the waveform is like this, till 1 millisecond that the from minus infinite to 1 millisecond the input is 0, and after 1 millisecond, 1 microsecond difference, that the output is changes from 0 volt to 10 volt, and it is maintained 10 volt till 10 millisecond, and after 10 millisecond of the difference of 1 microsecond it will be a 0. So rise time is 1 microsecond and fall time is also 1 microsecond, and I am just putting it here. Okay, you can give that name also. That name you can put it that net label net. So I can write it that is V input. So this is your V input, and this is your uh, V out. Okay, let's say it is like this. Okay, and this diode, you are using a diode. So for resistor, capacitor, inductor, there is no any requirement of any directive. Of course, if you are using diode, you must have a define it. Okay, what is the on resistance, means when it will on, what will be the on resistance, what will be the off resistance, and what is the that cut-in voltage. So for this we are writing some netlist, that is spice directive. So I am writing in this way ki dot model. Okay, and that is, this is D1 because this is a diode name is D1. So D1 and D, and you can write it inside that ki okay, the R on is nearly, I am saying that that is very small. So I am writing that is 0.01 ohm, and R off equal to 10 giga ohm. That is very high because in off matlab reverse bias. In a reverse bias, that ohm is very high. That high it is means that is 10 giga. I am just assuming that 10 giga. It's up to you. Okay, and V forward, that VFWD forward matlab forward, that cut-in voltage is what I am just thinking that is 0 volt. Okay, you can change it that 0, 0.7, 0.1. Okay, you can take as per your requirement. And just now I am taking the forward, the cut-in voltage, that is ideal voltage, just like ideal voltage. And this is the definition of, okay, so this is the definition of diode. Okay, okay, and let's simulate it. Okay, I am simulating this for 20 millisecond. Why? Because after 10 millisecond it will be 0 for a long period of time. So I am taking for a 20 millisecond what will be the output. So just check it. Okay, I am just figure out it what the input. The input is changing at 10 millisecond. Okay, and it has become a 10 volt after 1 millisecond. Sorry, after 1 millisecond the input is changing is 10 volt, and it is switching after 10 millisecond become a 0. So that input waveform as per our requirement is like this. Let's talk about output voltage. So the output voltage is like this, means it is that on is have a some value. That's why it is showing some that have a some graph that is like this. You can make it R on is as much low. Okay, so you can make it that is R is 0.001 ohm. Okay, and let's check it. Okay, what will happen if, okay, okay, so it is showing like this. Okay, we have a some effect on by the R on. If this R on is very small, as per that it will showing that like this. So the output, it is moving in such a way. Okay, the diode is changing, but it is not rising to 10 volts suddenly. It is showing, it is going for a, after some time it will be going. Why? Because that is have some diode is R on, and then it will be falling from 10 volt to something like this. Okay, why? Because what is happening basically here, just check it, uh, that the input voltage is given, the input voltage is 0 to 1, 0 to 10 volt in a 1 microsecond, and after 1 millisecond, and after 10 millisecond the input becomes 0 from 10 volt to 0. So if you are looking this circuit, what you analyze, okay, that the difference in analyze and in the difference of the simulation. In the analysis part, I am just assuming that diode is on. So if the diode is on, so this input is connected to V out with the diode is on. Of course, that diode have a some internal resistance, that R on resistance, so that it is taking some RC delay, and that's why it is have a, that capacitor have a charge. Okay, if it is ideal diode, so this diode will be become a what you can say that 10 volt. Okay, that is rapidly changing from 0 to 10 volt, and then it will be when that diode will be off after 10 millisecond, the diode will off, that is behave like a 10 giga ohm, that is very high as compared to 10 giga ohm parallel with 1k, so near about it is 1k, and that capacitor is discharging the path of 1k, so capacitor is discharging, so that's why it is looking like this, that the in a on time that V out is following V input, but after 10 millisecond when the diode is off or reverse bias, so it is not it is not like that ki okay, that capacitor is discharged with the resistance path, it is discharged with the 1 kilo ohm resistance. Is it okay? So this is the way you can analyze on a paper, and once you simulate it to your file, of course that simulation will give you result ki okay, that just like a MOSFET, in a MOSFET you are thinking that ID is equal to half mu n CoxW by L VGS minus VTH ka whole square, but if you talk about a whole equation, so there have a lot of effect, that is 1 plus lambda VDS, and that lot of effect it have. So that simulation part and the analysis part, maybe I have some fraction of difference. Why? Because of course that tool will take a lot of understanding inside that. Okay, of course this is designed by the help of skill language. So a lot of thinking it is have okay, the diode have a some initially that resistance, and that's why that RC is charging, but it is not charging as to 10 volt, it will be charging after 9 volt, it will be like this. Okay, so this is the way. Okay, and this that the input is become a output and the resistance is present here. Okay, so this is the way you can make that. Okay, changes that we forward also, it's up to you, you can change that question in this way. Okay, okay, just right click on this and make it 0.7, or I can make it 1 volt. Okay, that forward, that cut-in voltage is 1 volt. So if that cut-in voltage, that is that diode is forward bias have a voltage drop is 1 volt. So what will happen? Of course, this is behave like what, that we have a supply. After once that is on, it will take that cut-in voltage. So what will happen? Just check it, that output side. Okay. So just I am simulating it. Okay. So this is the input voltage. Let's talk about the output. So output is not changing. Why? Because that you have a V forward. Okay, that V forward. Okay, just check it here. What will happen? So you must have that changes of V forward also. Oh, not. Why this is not changing? Is there any change on that? V forward is 1 volt, or make it cut-in voltage is 3 volt or 4 volt, and this is make it 100 giga. Okay, what will happen? Okay, so just check it. Oh no, this is not changing by the help of V forward. V forward is not, that V out must be less than 10 volt, and it will be reaches to 9 if it is forward bias. So that's why it will be make it 9 volt, but it is showing that 10 volt. Okay, why this is? As per the understanding, we know that if the diode is forward bias, so this diode have a, that is have a voltage drop is 1 volt, so that V in is 10, so this is one drop, that is become a 9 volt, that capacitor will reaches to 9 volt, and whenever this is forward bias. Okay, and after that it will be discharged from the capacitor. Okay, that after 9 volt, but it is showing that okay, that is there is no any changes of. Okay, maybe I am maybe it may be problem of that directive, but I think so that this is correct. Okay, please check it that V forward is correct or not. Okay, V forward maybe it is correct, or maybe this is not working, so you please check it. Okay, V forward is what? Okay, so you can. Okay, so there is nothing, just you can think in a way okay, that just go for the LTSpice on a Google and check it, what is the model file of the diode. If the model file of the diode have a V forward is different, you can place it. Okay. Okay, it's up to you. Okay, there is nothing. Okay, there is no any problem, but means you must have a understanding of the circuit. The circuit is just explaining in a way, okay, okay, when the input is high from 0 to 10 volt, so that when the input is high, so this voltage is 10, so this will be reaches to 9 because the cut-in voltage is 1, or here it is 4, so this will be 4, that is 6 only. Okay, so why it is not happening, just check it. Okay, you can just check that model file of that diode. Okay, okay, so let's talk about the another circuit. Okay, you have a circuit in a such a way, okay, you have a one that supply here, and you have a diode, that the diode is like this, that path is like this, that control R. Okay, and you are using that resistor here. Okay, and this is connected like this. Yes, is it okay? Yes, it is connected like this, and that this is grounded, and you have one more capacitor is connected, that is like the capacitor is connected like this. Okay, and this is connected like this, and you have a one more supply that is make it 5 volt. So this was the question we discussed in a class. Okay, and you have a this is that 5 volt as a input, and this input is changing. Okay, make that this is till 2 millisecond it is 0, and after 2 millisecond that is 2.001 millisecond, it have a change of 10 volt. Okay, and it is maintained 10 volt till 10 millisecond, it is maintained this is 10 volt, and after 10.001 millisecond it will be 0. Okay, you can make your own waveform there. Okay, and that if you have a simulation tool, so you can use as per your understanding what you can design your own circuit. But I have a request for you ki just firstly solve question at your end with the pen and paper. Okay, if you are good in solution with a pen and paper, so you that solution, that simulation is only help you. Okay, this is not a result. Okay, whenever if you are not good in the understanding of the circuit design, that simulation will give that only result. If you are go for the common source amplifier or any amplifier, that gain is given. Okay, that you find that 20 dB or 40 dB or 60 dB as per the requirement, or you find that 10 megahertz bandwidth. But how it is happening, what is the pole, what is the zero, what is the internal resistance, how this first order pole and how the second order pole is affected, how you can make that Miller indices, how you can use a Miller Miller effect in your question. So that is very important. So of course, once you go for the simulation, that is okay. That simulation will help you. Okay, you can analyze that how that waveform is working, how that waveform, how the capacitor is charging or discharging. But before that, you must go with the pen and paper. Okay, you must work on that how it will work. How can you explain your answer? Because if you explain yourself, of course you can explain to others. Okay, so this is the question. Okay, and of course you have a okay, we miss I think diode here. There is a diode also, so we can use a diode also. Okay, let's cancel it. Okay, let's cancel it. Firstly, I am using a diode here, and then I use a capacitor, I think. Okay, we can delete this one. Okay, so just use this like this, and this is diode D2, and I am giving that the value is 1 microfarad. Okay, and this resistance have a 1k, that is 1 kilo ohm, and this is 5 volt, and this diode D1 and this is diode D2. So you required a two model. Just I am going for the spice directive. I am writing dot model D1 For D1 I am writing the condition, that is R on equal to 0.001 ohm and R off equal to 10 giga ohm, yeah, 100 giga ohm, it's up to you. Okay, and V forward VFWD is equal to 0. So this is model file for that uh, D1. Let's talk about this is your model file. Oh, sorry. So you can use a model file here. So just write it dot model uh, D1 to D R on equal to 0.001, R off equal to 10, yeah, 100 giga, and VWD is equal to 0. Okay, and you just place it here. Okay, of course for D2 also you required some condition, so I am going for the, okay, you go for edit spice directory or you can write it here also. Okay, similarly you can copy it also or you can write it here. It is D2, it's not D1, it's D2, and I am writing in a way R on is 0.001, R off equal to 10 giga, and VFWD is 0. You just put it here, and this is D1 and this is the case of D1 and this is the case of D2, and both diode. Okay, you can change that condition also, D1 and D2. This is the D1 diode and this is the D2 diode, and this is 1 micro. It is given that everything is given. Okay, and you can give the name also, because as per the name it is that you can understand easily. Okay, and okay, and just run it for 20 millisecond. I want to simulate it, so that input waveform is like this as per the requirement. Okay, till 2 millisecond it is 0, after 2 millisecond become a 10 volt, and it is maintained to 10 volt till 10 millisecond. After 10 millisecond becomes 0 to 20 millisecond. So what will be your output? Just check it, what will be the output. So just think in a way, you have a diode, okay, and the diode is connected with a capacitor, and the DC supply 5 volt is always present. So your capacitor C1 is open for before T1 is equal to 2 millisecond. Before 2 millisecond that input is grounded and D1 is connected, resistance is present, that capacitor is act like a open circuit, and the diode D2 is that have a 5 volt with the capacitor. So there is no meaning that Vout is not present here, Vout is 0. Okay, so just check it here. So that Vout is 0. Okay, and then what will happen? So as per that you have the diode is on. So if the diode is on, so this is that supply is high, that V input is high as compared to V out. So V out is 0, so that's why D1 is forward bias. So if the D1 is forward bias, so D1 is connected with that V out, and this will be ideally it will be 10, but it is not 10 with that some resistance drop, so it is less than 10, and it is maintained that whenever that input is high, and once that input will low, it will be try to that as per that this will off, this capacitor will, this diode will be like this. Okay, and this is happening here. Okay, so this is the way you can. Okay, so this basically what is happening. So that V out is directly related with the V input, and the C1 diode is not, C1 is not affected here. Okay, the C1 is not effect here. Why? Because this is the input supply have a 5 volt and diode is connected in way. Okay, so that the V out is 10 and this capacitor have voltage 5, so diode is remain open. Okay, and once that input is low, this diode is not work anything, this capacitor is behave like open and it is maintain that. So this is the way you can analyze your circuit. Okay, and you can go for that simulation also, you can work on it, okay, what is happening. Okay, and as per, okay, maybe the question is different. I don't know what was the question. I think was that was the question. You can design your own circuit, okay, and simulate it, and you will find it, okay, what is the output of that. Okay, so just on the basis of the tool, I just want to explain it, ki how can you simulate with the diode. You have a some spice directive, that is dot model. On the basis of the dot model, you can the spice directive file of the model of the diode file, and you can simulate it. Okay, there is nothing, okay, you can work on it. And this is very, and if you want ki what is happening here, you can check it on the LTSpice. You can go for the LTSpice and you have a every model file, you can check it, what is the model file of the diode, you can check it. Okay, so this is the way. Okay, let's talk about that switch based circuit. Okay, when you have a switch base, what was that switch based circuit, how you can simulate the switch based circuit. So you have a voltage source, okay, and we have a capacitor, and that's last class we discussed. We have a three capacitor here, that is C1, C2, C3. Okay, and we have a switches also. So I am going for switches, go for component, and we have a switch SW. Okay, we have a SW. Okay, just go for SW and place it. Okay, you have a this direction. Okay, so press Control R for rotate. Okay, and this is the direction. So I am just connecting in this way. Okay, this is first switch, this is second switch, and this is third switch. We have a three switches. Okay, and that connection is like this, and that this input voltage is connected here, this switch is connected here. Okay, this is connected here, this is connected to here, and this is connected to here, and this is connected here. Yes, and you can check it. Okay, all our capacitor, that second terminal is grounded, so I just connect it like this. So this was your V1, this was your V2, this was your V3. You can give the name also, that is V1, V2, V3 as per your question. You can put it V1, V2, V3. So this is okay. Oh, sorry. So just make it V1 here. Okay, this is not allowed here in LTSpice. You can in a cadence you can. Okay, so this is V1. This is V2. Okay, and this is your V3. Sorry, this is your V3. This is your V3. So you have a V1, V2, V3. Okay, and I am just giving that the voltage, let this is 5 volt. Okay, and this capacitor, I am just making that all that capacitor is same, that is 1 micro, 1 micro, and 1 micro. Okay, just make it that all that capacitor have a 1 microfarad. I am connecting here. Okay, the ground, and this switch have a supply. Of course, we will control this switch. So how can we control this switch? By the help of that supply. So we are controlling this switches with the supply. Okay, so I am just connecting this one like this. Okay, and I am connecting this way. This one is grounded, this one is grounded, this one is grounded, and you can make this one is also grounded. Okay, you can connect it. Okay, you can ground here also by the help of this. Okay, so you can, and this is A switch, this is B switch, this is C switch. As per the no, how can we give that? Okay, I am going for advance, and I am saying that okay, till 5 millisecond, that input is 0, that this is for what, that this is logic 0. So for this switch you are saying that for 5 millisecond it is -1. Here you have -1. -1 plus 1 is behave like switch on and switch off. For -1 this is switch off, till 5 millisecond it is off. 5.001 millisecond, in a 1 microsecond difference it will on, and it is on till make it 10 millisecond, it is on till 10 millisecond it is maintain high, and after 10 millisecond it will be 0. Okay, so that till 5 millisecond that logic is off. After 5 millisecond it will be high and is maintained high till 10 millisecond. After 10 millisecond it is 0. Okay, so this is, let's talk about this one, that B. So what is B? So I am just saying that ki after 15 millisecond it is after the till 15 millisecond it is off, and after 15 millisecond it is on, and it is on till 20 millisecond, and 20 millisecond it will on. After 20 millisecond it will be off. Oh sorry, -1. Okay, so till 15 millisecond the B switch is off. After 15 millisecond the switch will on. Till 20 millisecond it will on, it maintain on. After 20 millisecond it again will off. Okay, let's talk about this switch. So till 25 millisecond it was off, and after 25.001 millisecond it is on, and it is on for an infinite time, for a large time. Okay, so after 25 millisecond the switch C is always on. So what is that output? So this is the way you can, okay, you can explain it. Okay, so this is for that. Okay, that you have a 5-volt constant supply, and this 5-volt constant supply is controlled with this switch. This switch, when this switch is connected, this capacitor have a voltage. Okay, and it is maintain that voltage whenever till this switch is connected. Once that switch is open, this capacitor will have a potential, and it will focus ki how this capacitor can discharge. Once this capacitor is on, this capacitor will discharge to C2. Okay, and till this connected, that capacitor C1 is C2 is connected to maintain the same voltage. After some time, means it will happen suddenly, and because there is no any resistance, and once this switch is connected and this switch is off, so this will discharge till some voltage, and it is maintained open. Why? Because this will open and this will open, so C1 have a same charge, it is maintain that charge, and after that C2 will discharge. Okay, so let's check it. So let's make it for 30 millisecond. So 30 millisecond, for 30 millisecond. Okay, oh, there is a problem, so we are not write the file of switch. So just go for switch directive. So you can write it dot model sw1. This is okay, you have a sw, you can change that name also. This is sw1. Okay, this is sw2, this is sw3. You can make the same name also, it's up to you, but means if you want a different switches and you have a different condition, so you can, the name is sw1, sw2 and sw3, and you can write it dot model sw1, and that is sw, and this, okay, and you can copy it. Okay, and this is okay. and again for this press Ctrl V, and this is for SW2, and go for Ctrl paste, and this is for SW3. It's up to you. Okay, and you can give that command also, okay, what it can, how it can work. Okay, so this is the model file basically. Okay, and now you can simulate it. Okay, so what is happening? Just firstly, I am checking what is that this A switch. So A switch is like this, B switch is like this, C switch is like this. So this is A switch, this is B switch, this is C switch. You can give that name also if you want. You can give that name, that is also that A, B, C. So how can you give that this is A? So this is A. Okay, you can give that name also B. So this is B, and this is C. You can give that. Okay. So now you can run it. So this is for, this is A switch, this is B switch, this is C switch. As you know that A is on for after 5 millisecond to this, and this remains same for 0 till B. Okay, and B will on at 15 millisecond, that logic high, and then after C will high. Okay, what will be your V1? Let's check it. V1, so V1 is 5 volt, and it is why 5 volt is always 5 volt. Okay, just check it. This is 5 volt. Okay, just check it. Okay, this is connecting. Okay, this is 5 volt. Oh, why this is, oh, this is showing a 5 volt always. Why this is showing that 5 volt? Maybe this is not on. It is 5 minus 1, that is 10, this is 0. Okay, okay, let's check it. Okay, I am just checking for switch RC circuit. It is connected, I think, so it will work. Why it is not working? Okay, just check it here. Okay, I am just checking it. Okay, why this is not working for this circuit? This is 10 volt. Oh, it is working. That PWL. Okay, maybe the DC voltage it not work. Okay, let's check it that this circuit is working and that this circuit is not working. Why this is happening? And that same thing is going on here. Okay, let's check that. Okay, that's why. Okay, make it like this. Okay, I am not giving 5 volt, I am giving in this way. Okay, till 2 millisecond it is 0, and after 2.001 millisecond it become 5 volt. Okay, just check it. Okay, maybe this DC source is showing the problem. Okay, now let's check it. Okay, so this is the input is always, what is your V1? Oh, now it is working. Okay, that this is this is happening. Okay, just check it. Okay, that the input, if you are taking that input in DC, so this is not working properly. It is showing some problem. But if you are taking the input is changing after 0 to 5, so it is working. That there is no just a simulation problem, or you can think in a way. Okay, so just go for simulation, and I am just focusing on what is A, what is B, and what is C. The switch A is looking like this. Okay, that switch A and switch B. Okay, okay, and this is switch C. So you can check it that A switch, B switch, and C switch. If I am working for V1, So V1 is high. V1 will, the switch is closed at this part, and it is closed at the 5 millisecond. It is closed, that switch is closed, and become the output is here, is 5 volt, okay, and is maintained 5 volt till what, when that switch B is closed, because that switch A is closed for 5 millisecond to 10 millisecond, and this capacitor is charged to 5 volt, and this will be open, the switch A is open after 10 millisecond. So after 10 millisecond, this capacitor does not have any path for discharging. So this capacitor have a voltage is 5 till the B will not on. Once that B will on, this capacitor discharges, and discharges with that 5 to 2.5. Why? Because this is that all the capacitor have same value. So this is 5 into C1 upon C1 plus C2. So 5 into 1 microfarad upon 1 plus 2, that is 5 upon 2, that is 2.5. So you can check it also, okay, you, if you want, you can check it, okay, that after that this time this voltage become a 5 volt and is maintained 5 volt, and once that B will on, this have a suddenly have a 2.5 volt, okay. So this is 2.5 volt, okay, and let's talk about what will happen of V2. So if you are looking for V2, so V2 is what, that is 0 till 15 millisecond. After 15 millisecond, it have a changes of that capacitor discharge, and it is try to discharge with the same level, and that voltage become a 2.5 after that B will on, and this C2 have a voltage of 2.5 volt, and it is maintained 2.5, where that A is also maintained 2.5. Why? Because after this part, after the 20 millisecond, this B is on. After this B is off. If B is off or A is off, so this capacitor C1 does not have any path. So lastly it discharged to 2.5 volt level. So after that, after 20 millisecond, there is no any path for discharging. This C have a only path to discharge, means C2 can discharge, means V2 can discharge, but V1 cannot discharge after 2.5 volt. Okay, so that means that after 2.5 volt level, that capacitor does not have any path for discharging, and that C2 have a path, this V2 have a path for discharging, and it is discharged after 25 millisecond to 2.5 to what, that half value is 1.25. you can check it also, okay, you can, okay, so this is that value is 2.5 and become 1.25 here, okay. And if you are looking for V3, so V3 is remain 0 till 25 millisecond. After 25 millisecond, it will be a 1.25 volt. You can check it here, there. So that one, that this is V3, that the color is this one, that is very gray, okay. So this is 0 till 25 millisecond. After 25 millisecond, it will be reaches to 1.25 volt. You can check it also. This is 1.25 volt. So that it is looking similarly, that the capacitor is charging, okay, and discharge with that, but here that there is no any resistance, so that's why it is rapidly changing from 0 to 5 or 5 to 2.5 or 2.5 to 1.5. Whenever you are solving this type of question, always focus on the switching time, because the switching time will decide you which capacitor is discharged and which capacitor is not discharged, okay. If you are looking for A switch, the A switch will off after 10 millisecond, so that supply is disconnected with that network, with that C1, C2 and C3, and that switch 2, that is B switch, is off after 20 millisecond, so that V1 voltage is not have any path for the capacitor. C1 does not have any path for discharging, so that's why that C1 will discharge till 2.5 volt level, and after that, there is no path, so it maintain 2.5. So whenever you have a capacitor and capacitor does not have any path, so it maintain that voltage. that infinitely it will be discharged. Of course, that capacitor will just discharge, just like a battery. You have a battery, just like you have a remote, you have a battery, and if you are not using that battery, so it will be charged for a long period of time. It will maintain that voltage level, okay, and it will long period of time, okay. It maybe take 1 year, okay. But if you are using for any working for any function, so it will discharge. So there, that the C1 have a function with the C2, but after some time that C1 is disconnected with the supply also, with the remaining circuit also, so it will maintain that voltage. So this is the way. This is ideal case. This is ideal case. So you just think in a way. But if you are going for the practical, of course, we have some resistance in the environment, so it will discharge. Okay. Okay. So this is the circuit and this is the waveform. Okay. Let's talk about, okay, if you are changing this circuit and I am using that one resistor here, so what that circuit will be. Okay. So just I am removing this and I am removing this also and make this and I am connecting one resistance here and one capacitor also, okay, and this resistance is 1k, okay. I'm just putting that 1k, and this is capacitor 1 micro, okay, that same value here I am putting, and this is your V3 and this is your what, that is your V1, this is your V2, this is your V3. Let's talk about this is that node voltage, you can put it, okay, or you can take that capacitor voltage, okay. So similarly I am just changing that, okay, I am not using capacitor at the end, I am using the resistor. So what will happen? So that waveform is changes after 25 millisecond or 20 millisecond when this switch is closed. This switch will close, the switch is closed, and before that it is remain same. So just check it. So as per you know that A switch is like this and B switch is like this, that similarly that switch is same, that A, B, C all are same, okay, and that switch is same for A is on for some interval of time, B is on for some interval of time, and C is on after 25 millisecond. Always it is like this. And be focus on this question, okay, that this is 5, this that capacitor, when this switch is on, the A switch is on after 5 millisecond, it become a 5 volt there, it is become a 5 volt, okay. Suddenly it is reaching to 5 volt, it is maintained 5 volt, then after that this switch is on, okay. Once this switch is on, this capacitor will discharge. And why this is transferring this charge? Because that this C1 is not connected with the supply. So till 5 from 5 millisecond to 10 millisecond this switch is connected. After 10 millisecond this switch is open. This C1 have a no path for discharging from 10 millisecond to 15 millisecond. After 15 millisecond the B switch is closed and this capacitor can discharge to C2, and we found that the same level, because and it is changing rapidly because there is no any resistance. So that 5 volt to 2.5 volt, because that capacitor, that the value is same. If you talk about V2 is changing after 15 millisecond. Till 15 millisecond this switch is open, so that capacitor does not have an initial voltage, so this C2 does not have any charge and it is 0, and this V2 is remain 0 till 15 millisecond. After 15 millisecond it become a 2.5 volt. You can check it also. So this is 2.5. okay, just focus till 15 millisecond to 25. Don't go for after 25 millisecond. Just focus for 15 millisecond to 25 millisecond. So from 15 millisecond that B switch is closed and till 20 millisecond it is closed. So these both have a 2.5 volt level, and that bucket is have a same level. So after that it can't be flow, okay. And the B switch is open after 20 millisecond. So that means that C1 does not have any path for right side or left side also. So that C1 have a voltage level is 2.5, it is maintained 2.5, where the C2 have a voltage is 2.5, but now after C switch is on, the C switch is on, this resistance is present on the right hand side, and resistor and capacitor is present, and here that capacitor is not instantaneously changes, or it is not rapidly changes from 2.5 to 1.25 volt, it is changing exponentially. Why it is happening? Because that current is finite. When this is 2.5 volt, you have a capacitor voltage and you have a resistance and you have a capacitor. So that capacitor have a initial voltage is 0, and you are checking in a way ki what is the current. The current is finite, that is 2.5 upon 1k, that is 2.5 milliampere. So if you are interested, we can think about the current also. So you can go for this current. So you can check it. This current is going for 2.5. This is the path. You can check this. Okay. So the current is maximum is 2.5. Okay, it is very near to 2 point, that is peak now, that's why. Or you can make that resistance and capacitor values high, so it will be looking properly. So this is near about 2.5 milliampere. Okay, I am just explaining in such a way, okay, this value is 2.5, reaches to 2.5, this is the peak. So this is 2.5, that initial, at once that switch is closed, this capacitor discharges with a 2.5 upon 1k, that is 2.5 milliampere. And once that this V4, this capacitor C3 is charges, the current is V2 minus this capacitor voltage upon resistance. Initially it was 0, so V2 minus 0 upon R. As per that capacitor is charges, that is V2 minus V4 upon R, and V4 is charging, so current is decreasing. So that's why current is decreasing, and current is decreasing exponentially. Okay, and what level it will be decreases, that that voltage will same, V2 minus V4 is 0, then that current I is 0. So that capacitor is discharges from 2.5 volt to 2.5 volt, from 2.5 to this is decreases and become a 1.25 there. It become a 1.25. That capacitor is discharges in a previous case is suddenly, or I can say that rapidly, from 2.5 to 1.25, because that the resistance is not present and the current is very large. But in this case you have a resistance, so resistance will limit the current, and it will not provide the sudden changes, or you can say that rapid changes is happening through a capacitor voltage. So it will limit, and it will be exponentially decaying from 2.5 to 1.25 volt. And V2 and V3 have a same voltage after 25 millisecond, because after 25 millisecond the C switch is closed for a long period of time, so it is V2 and V3 same. Okay, and what about this capacitor voltage? This capacitor voltage, this is, if you are looking this way, okay, what is happening here? If I am just going for a in this, so this is the capacitor voltage. Capacitor voltage is 0 till 25 millisecond. After 25 millisecond it is 0, it is not 1.25, it is 0. After that, as per the current is decreases, this capacitor is voltage increases, because the current is dependent on the V2 minus V4 upon R, and initially V4 is 0, that's why it is showing that maximum current, that is 2.5 milliampere, because as per I is equal to dq by dt and q is equal to integration of I dt, that on the basis of delta t time, that current, that charge is increases and voltage is increases, and but the current is decreases, so that the capacitor is charging, but it is not charged to 2.5 volt, it will discharge to 1.25. So you can think in a way you have a one capacitor, you have a one resistor, or you have one capacitor here. So that not meaning that the capacitor will discharge fully. It will discharge to some level, but it is not rapidly happening. It is happening in the terms of exponential. That C2 capacitor is discharging exponentially, where that C3 capacitor is charging exponentially. In a previous case, that is A switch for B switch, that this is suddenly, or you can say that rapidly happening. I am not saying that suddenly, this is rapidly happening. This is not instantly. This is called as rapidly happening because that current, the resistance is zero. If resistance is zero, the current from one capacitor to another capacitor is very large. So that's why it is rapidly changing with a very small duration of time. But once you have a resistance, whenever you have a resistance, it will not provide a rapid changes. It have a tau. Of course, if you have a tau, so the tau will affect in your question and it will discharges exponentially. You can increase this time. You can make it R is 1K to 10K. It will discharge very slowly. If you make it R from 1K to 100 ohm, it will discharge very fastly. I am talking about C2. Similarly, C3 will charge fastly if your tau is small. If your tau is very large, so that C3 will charge slowly. So this is the way, okay, this is the way you can understand. And I have one question for you. Okay, you can go for this and just not use a capacitor here, just use a one resistor. Firstly, solve with pen and paper. Okay, you have a resistance only. What will happen after that switch C will close? The C switch will close and you have only resistance. There is no any capacitor. What will happen? So you can understand in a way. Okay. So this is one of that complicated question because most of the student is thinking that V2 it discharges from 2.5 to 0. It will not discharge from 2.5 volt level to 0. It will be discharged from 2.5 to 1.25 and it is discharging exponentially. The charge conservation is working here and C2, C3 will make that a level where that both capacitor voltage will same. Okay, so this is one of that very good question. Okay, please work on it. I hope you understand these questions. Okay, and work on that simulation. If you are interested for a simulation directly, you can go. But I always suggest the student, please go with the analysis part. Firstly, understand the concept, what is happening, and then simulate it. Simulation can done by anyone. That third class, fifth class student can simulate it. If I am explaining, okay, so this is happening, okay, this will simulate, okay, but the analysis is very important. You must know, okay, how C2 and C2 is discharging and C3 is charging, and now it is not going to 2.5. C2 is not going from 0, C3 is not going from 2.5. It will be have a some limit. Okay, and the question you can change in this way, okay, that capacitor value is changed, that here it is 1 micro, 1 micro, 1 micro, you can change it 2 micro, 1 micro, 3 micro, it's up to you, and use a conservation, charge conservation, and simulate it and find it. Okay, what will be the output? Okay, so I hope it is enough for today, and this is over from the RC circuit, and this is a basic part of RC. I am not going for that. This is everything of RC. This is the basic part of RC. Just use a MOSFET here, it become a pass transistor based question. If you use a transmission gate, it become a transmission gate based question. That the MOSFET is just like a switch in a digital design. Okay, so you can, okay, you can work on it. Okay, I am just changing the switches in the position with the MOSFET. Okay, so it will be a complicated. Okay, and if you want more complication, we can use a parasitics also. That MOSFET have a diode as a parasitic. We can introduce this part also. Okay, so this will be a good question if you try to in such a way. So RC part is over, and this is a fundamental RC part. I am not saying that this is overall RC. This is a fundamental RC part. You must work on it on the basis of the concept, and you find the questions in the interview. You can search it. Okay, the TI question, ST question, any question. just work on it and find it, okay, can you solve that question, can you work on it, can you find the analogy, what is happening here, what is happening here, because in an interview you don't have a simulation, you have a pen and paper, on the pen and paper only you can explain your answer. Okay, so I think it is enough for today. So let's start on our next class is the MOSFET. Okay, thank you so much everyone. Bye bye, take care.